Welcome back. So, as I was talking about that about this part in the last lecture, so I will just explain here that what happened was, because if you take this, consider this as an Andaman island, then there was a push here. So, this portion of the Andaman, that is your west coast, got uplifted, pushed up, and the east coast subsided. So, we were able to see this clearly because of the low lying area where under the water, and the tidal water, because earlier it was like this. So, tidal water coming here and going back, but because of the tilt, the tidal water started coming to inundating more areas. Okay. Whereas this portion, earlier it was like this, it was coming, but now the most of the part remain exposed. Okay. So, we will quickly look at the different landforms from Andaman. So, this is an Andaman island, and the trench portion is been marked here. So, this is the subduction zone boundary between the two plates. Okay. And we will see some examples from this portion here as well as this portion here. These are the smaller islands which are sitting a little far away from the Port Blair. Port Blair is the city located over here, and this portion also will try to see some landforms. Okay. So, this I have already discussed about, that we have like this portion, the area was subsided by almost 3 meters during 2004 earthquake, and further these are all areas which subsided by ranging from 1 meter to almost 3 meters here, whereas this portion got uplifted, that is the eastern the west coast got uplifted and the east coast subsided. Now, as we were talking about the sea notches, the best sea notches which we came across were from Kurmadera along the west coast of Andaman, in this portion here. So, again the sea notches are the erosional features which are formed because of the tidal wave action. Okay. So, this sketch, it shows that the waves coming in. So, if you are having the rocky coastlines, then you will be looking at the sea notches. If not, then you will not be able to see the sea notches. So, what we see here is that there is an erosion because of the wave action here, and slowly it develops a very carved like C shape feature along the coastline because of the high tide and the low tide area. Okay. So, this is what we say, that this portion is your the average or the mean tidal level, and this portion is your low tide, and this portion is getting eroded because of the high tide. So, if you take the sea cliff and then wave action here, so you have the low tide. So, this will be the bottom part of the sea notch, and this will be the top part of the sea notch. Now, suppose there is a change in the water level. If the water level goes down, then you will have the formation of sea notch somewhere over here. Okay, like that. Okay. But if the water level goes up, then you will have the formation of sea notch somewhere over like that. Okay. So, you will have the different level of sea notches in the area, and if suppose the sea level has gone up, then you will see the sea notches developing somewhere on the top of this. Okay. So, in some locations what we find is that you have the multiple sea notches developed along the coast. Okay. So, such areas are important for us to identify if we come across in the coastal region. So, if you are for example, if you have here, then this is the elevated surface, or we can say marine terrace, and this is sea notch 1, and this is sea notch 2, and this is sea notch 3. So, this means that if we look at this one, then you have this is the mean tide level, whereas this is the high tide level here. So, from here if you look at, then we will have the high tide level here, then you will have the low tide level here, and this will be your mean tidal level. Okay. And similarly, you can extend this further now. Now, this 3 notches, if suppose we are looking at this, are indicative of that that in the past the sea level was up to this portion. Okay. So, the water reached up to this portion, which was capable in developing this sea notch, and further we see that the sea level has gone down. Either the sea level has gone down or the area has been uplifted. Okay. So, in most of the regions, scientists try to look at the sea notches. Of course, they are erosional features, but they try to look at the sea notches and try to understand the past sea level changes. Either it is because of the climate or because of the tectonic activities in that particular region. And in Andaman and Nicobar area, because we are close to the subduction zone, and one of the best example, the lesson which we learned was from the 2004 earthquake. We understand that this area must have gone under the influence of tectonic activity in past also. Okay. So, this 2 diagrams, it shows that you have the formation of sea notch, and then if the area is uplifted, then this remains as an older sea cliff and sea notch here, and then you have the formation of the new sea notch because of the lower portion of the area getting exposed to the ocean. So, in this case, the sea level remain unchanged, because only the area got up. Okay. So, the area was uplifted. So, for example, if as I was telling that you have the contact between the ocean water here and the cliff, the marine cliff or the coastal cliff, then you are having the erosion which is going on will be somewhere here. But suppose you uplift this, okay, then the erosion will be here, and this portion will be seen sitting above the present day sea level. So, this as the satellite Google Earth image of Neil Island, which is one of the beautiful island in Andaman island chain, which is located east of Port Blair from the Andaman mainland. And what we found here, that we were able to see multiple terraces developed here as well as sea notches. Okay. So, let us see quickly what it shows. So, we have again in this area we found the sea notches. So, you can see one sea notch here, we can see here also, okay, and then another one is here, and third one is sitting over here. So, 3 sea notches we were able to fix, and then one more is the younger one which is developing here. Okay. So, in total we have the prominent ones are this one, this 3, and then the smaller one is coming up in this portion. So, close up of that, if you see, you have clear cut sea notch here, another smaller one is coming here, erosion is going on, another one is sitting here and further on the top. Okay. And then we also found the wave cut platforms over here. So, this is the older one, and then present one platform is sitting here. Multiple sea notches from, so this area is from the east coast. Now, coming to the west coast of Andaman, again we were able to pick up multiple sea notches. So, this is the platform here, and the sea notch has been formed over here. So, we found multiple platforms here, which I will show. So, this is typical of mushroom shape sea notch, and this definitely could be or could be related to the uplift in this region. Okay. So, if we consider that this was the erosional level of the previous sea level where the ocean used to be, but now the ocean level is here because of the uplift. This portion is subjected to erosion. One of the best example we came across from Japan, where vertical displacement during 1703 and later earthquake was been identified based on the land level change. Okay. So, this is from the Miura and Boso Island, where the Boso Peninsula, the Miura and Boso Peninsula, they were been affected, and they indicated a clear example where 2 earthquakes took place and they left their signature along the coastline. That is, one in 1703 and another was in 1923. Okay. So, in short, what the scientific groups have done is that they have also tried to date the because when there is an the tidal levels coming up to this portion, then there will be and the areas where the organisms will be the survival lines for the organism, but once it is exposed, they will die. Okay. So, that what they picked up and they dated. Okay. So, the elevation measurements of the uplifted marine shells indicated that the lower assemblage emerged during 1923. So, this one it emerged during 1923 and this was older. Okay. And whereas the uplift of the upper assemblage is most likely correlated to 19 and 1703 earthquake in Kanto region. Okay. So, this what they have used as a marker to understand the land level change, because the sea level remain almost same during this period, but the area has gone up, and this is clearly indicated by the dead shells, the marine organisms along this line. Okay. So, they dated this and that helped them to conclude or infer that this 2 signatures of the dead marine shells are correlated with the uplift during 1923 and 1703. So, this is the example here. So, this portion is the present day erosion level here, and this is the uplifted. So, this is an older erosive platform. So, area has been moved up or uplifted by almost 1.5 meters, and this was during 1923 earthquake. Okay. So, earlier erosion, so older erosional platform, now the present erosion is going on over here. This is a close up of that. Okay. So, this is an indicative of this is an older one. So, this was the surface which was subjected to erosion until 1923 AD, and after that this is the area which you see here. Okay. So, we were talking about the wave energy concentrated on headlands. So, you will have the erosion because of that, and if you are having the configuration of the shoreline slightly curve, and the waves are approaching in the different direction or angle as compared to this one, you will have deposition in the bay areas. Okay. So, wave cut or shore platforms, they are basically the horizontal surfaces formed along the rocky coastline termed as wave cut shore platforms. And if you see, this is an example again from the Neil Island. So, a very flat area is exposed to erosion, which is this is the indicative of the present day shore platform of wave cut platform. So, again from Andaman, what we identified along with the cliffs, the sea notches, okay, we were able to pick the platforms, the older platform, erosional platforms or shore platforms, and along with that the respective sea notches as well as the present day erosive platform. So, shore platforms. Okay. So, if you look at this one, this is the wave cut platform 1, this is the present one. Okay. So, this you are having WC2. So, this is the second one. So, the sea level was up to this, which was eroding this platform, but now it sits here. So, the area has been uplifted, and the sea notches which we see is almost like the top one here, this one, another one is this here, third one is this, and the fourth one is this one, which is related to. So, if I just put here, then you have this one here, which goes like that. Okay. So, you have the erosion going on here, then you are having another one, and then small one is sitting here. So, this could be related to some small fluctuations during that time, but this is the major one, and then you have this one here, and third one is sitting here. Okay. So, if we find some signatures or the remnants of the marine dead cells here, we will be able to date this sea notches and talk about the history of tectonic uplift, or at least we can say the land level change or sea level change in this area. So, this is again the wave cut platform here. Along with that, we see the beach, and this photograph was taken aerial photograph after 2004 Sumatra Andaman earthquake. So, water used to reach up to this because the waves will result into the formation of beach here. So, the water used to go and come back here, that is your linear flow pattern will result into the formation of beach, but now what is happening is this whole portion is been exposed, okay, to the erosion, and this is forming your wave cut platform, or you can say shore platform, and this was because of the uplift in this region. And this photograph is from was taken along the west coast of Andaman and Nicobar Island. And another important feature which we see as we were talking about the fluvial terraces, we come across usually the marine terraces, and again the marine terraces are the abundant platforms during the different sea level. So, present sea level, you have this erosive cliff, and this flat area is your marine terrace. Okay. So, here what we see is at least 3 marine terraces, and further if they are drowned beaches, okay, that also one should take into consideration when we are talking about the tectonic uplift or subsidence or sea level change. So, this is the same example which shows the process resulting into the formation of cliff, sea cliff and sea notches. So, if the water recedes because of the uplift or because of the sea level change, then you will come across that this area will exposed and result into the formation of a bench like feature, which we say the marine terraces. So, this photograph if you look at, then what we see is and we have one surface here, another surface here, and then third is drowned here. Okay. So, we see the drowned marine terrace in this region. This photograph was taken from Kamota Island in the to south from south of Port Blair. Now, looking at marine terraces, this is what it looks like. So, you have the flat surface and the cliff here. So, you may come across multiple marine terraces. Okay. So, multiple marine terraces, again example from Boso Peninsula. So, what did they did when they looked at the area here, they were able to pick multiple terraces in this region. Okay. And these are the boundaries of those terraces, and those terraces were been correlated again, as we were looking in one of the slide, the sea notches. So, we were having the notch or the wave cut platform here like that. Okay. So, this was 1.5 meter and what uplifted during 1923 earthquake. So, another one, the older terrace at the higher level was correlated with 1703 earthquake, and then the lower terrace was correlated due to uplift during 1923 in Boso Peninsula, Japan. Similarly, further more terraces were been picked up and they were been correlated with different events. Okay. So, they have dated those surfaces and they have correlated this with different events. So, one what we see here is these are the one here. This is the youngest one close to the ocean, okay, 1923, this is 1703, and then further older one they have correlated with 2950 before present, that is events which were been recorded at that time, then 4900 and 7000 years or so. So, this is again an example of the wave cut platform which one can see from the 1703 earthquake. This was the older one, and then this was the uplift at that time. Another one we see, this is the present one, and this platform existed until 1923. So, after that, because of the uplift of the area, this is the present wave cut platform or the bench which one can see in Boso Island. Another common feature which you will come across along with the spit, as we have discussed that this will develop because of the longshore currents. We will have the enclosure of, suppose this the spit extend further this side. So, this will result into the enclosure of the water body, and that what we term this as a lagoon. And Tambola is basically the landform which is connected with the mainland through a very narrow bridge type feature in the area, and that is again related to your. Again, let's look at the depositional landforms. So, depositional landforms will come across basically mostly the beaches and tidal flats, coastal dunes, salt marshes, spit and bars, and beach ridges, barrier islands, and mangroves, okay, and Tambola. So, the previous slide which we were looking at, the mainland here, and then extension of the narrow way. This is again because of the depositional feature. Okay. So, coastal depositional landforms composed of loose sand and pebbles. Sand produces wide flat beaches. Okay. So, close to the coast you will have, if there is a depositional area and suitable area for the tides to come and deposit, then you will find most of the areas you will find the beach formations. Okay. Then one of the best beaches from Andaman. So, you have the sea cliff here, as well as a very semicircular feature here in the Bay Area, and the formation of beach. An example of beach from Andaman. So, this I will not go into details, you can just go through it. This is what we were talking about, the lagoons and the spit and tambolas. Okay. This is an example of spit, and spit has resulted into formation of a lagoon here, enclosure of this the extension of spit, and tambola is connected through the depositional feature here with the mainland. So, spit and beaches also will result into the formation of lagoon or the backmarsh or the brackish water. Now, another important part which we will be coming across when we are talking about the tsunami deposits getting preserved, for us it is very important to identify the environment, whether it is an lagoonal environment or the lagoonal environment changed to the beach environment, or we have the backmarsh. So, usually what we find is that if this is the ocean area, and then you are having slightly like this topography, and you may come across, I will just draw it again, you may come across like you have, so you have a beach ridge, and you may come across another beach ridge, you may come across another. So, you have the deposition of the beach here, okay, and this is your beach ridge, and this is your swell, and this is again the beach ridge, and this is the swell area. Now, mostly what happens that when the tsunami comes and it will erode. So, this is, suppose this is a vegetated area here. So, this will erode and deposit the material in the swell region. Okay. So, most of the time what we do is we try to locate such geomorphology in the coastal region and try to hunt for the tsunamis. Okay. This is a photograph of the development of the lagoon in Car-Nicobar area from Andaman. So, lagoons are enclosed and protected by barrier beach. So, if you go across this, then you are having wonderful beach. So, this portion what you see in the light, the brighter light is the ocean side, and then we walk down through. If you walk down through this area, then you have the beach ridge here, and then behind this you have the lagoon. So, if I put the topographic profile from this side, then you will have something like flat and then coming up and then getting into this one. So, with this I will stop here, and will discuss few more features and the landforms in the next lecture. Thank you so much.